Hey, in our last video, we delved into the basics of Python classes and we cover essential concepts such as how to create a class, creating objects or instances of a class, special and regular methods, and how to associate attributes to a class. We also introduced the use of getters and setters. And building on these fundamentals, today's video will focus on a power concept or a powerful concept in Python, the inheritance. So let's explore how to harness the benefits of inheritance in Python. When creating a class in Python, you'll encounter different syntax variations, and the standard approach involves using the keyword class followed by the entity's name and a colon. However, another syntax commonly seen involves open and close parentheses after the entity's name with the name of an existing class inside. For example, is this Android class. And this syntax signifies the concept of inheritance. In this example, it reads as Android inheriting from the phone class. The format explicitly shows that this class is a subclass or a derived class, and it creates a relationship with the phone class. And this relationship allows the Android class to inherit existing attributes and method from the phone class, and it showcases the power and flexibility of inheritance in Python. And here I predefined the pawn class by introducing an init method. This method includes two additional input arguments, the type and a color with the default value of red. And upon object creation, these arguments get assigned to the corresponding properties of the class instance. Additionally, I've incorporated two new methods, getType and getColor, which simply return the type and color of the objects. And recognizing that the pawn class alone cannot represent all types of pawns, I've expanded our class hierarchy by introducing two additional classes, Android and iPhone. And these classes inherits from the pawn class, establishing a relationship that allows them to access all the existing attributes and methods available in the pawn class. Now, upon attempting to create a new object of type Android, we've encountered a type error indicating that one required parameter is missing. And this occurs because the Android class that does not specify an init method. And remember in Python, when you create an object of a class, the init method is automatically invoked. And if the class itself does not have an init method, Python will look to its parent class, in this case is the pawn class, and invokes its init method. Or the error arises because Python expects an init method in the Android class. Since it doesn't find one, it falls back to the parent class init method, and any missing parameters trigger a type error because the init method on the pawn class requires the type input arguments. So to address the initialization error, we've updated the code by specifying Android as the type when creating a new object of type Android. This ensures that the required input argument for the init method in the pawn class is supplied. So now once we execute this code, we don't get any type error. Let's also create an object of type iPhone and specify the type as iPhone. And with objects of type Android and iPhone in hand, we can now invoke methods from the parent class such as the getType method. And this demonstrates the inheritance principle in action. Even though we don't explicitly define a getType method in the Android and iPhone classes, they inherit this method from the phone class, and this showcases the ability of objects created from subclasses to reuse existing methods from the parent class. Now, recognizing the redundancy in specifying the phone type when creating an object of type Android or iPhone, we can streamline the process by adding an init method to the subclasses. In this updated Android class, an init method has been introduced, and inside this method, we invoke the base class method from the phone class and explicitly indicate Android as the phone type. And now by adding the init method to the Android class, we've successfully eliminated the need to explicitly specify the type of the phone when creating objects of type Android or iPhone. This simplifies the object creation process, making it more intuitive and reducing redundancy. Now, creating an object of type Android can be done without explicitly providing the phone type. So now once we execute this will not produce any type of error. And similarly, we can do it for the objects of type iPhone. Now we can create an object of type iPhone without specifying the type iPhone. So for example is I1 is equals to iPhone, and we can leave that blank. If we execute that, we'll not get any type of error. Now if we inspect the type of A1, we see that this is of type Android. Now if we inspect I1, we can see that this object is of type iPhone. And in here, we redefine the phone class and introduce two new methods, the download app and install app. We recognize that the phone class alone cannot represent all types of phones, and consider Android and iPhone for instance. While they share common attributes and method, they also differ in certain aspects specifically when it comes to downloading and installing apps. Android devices utilize the Google Play Store, whereas iPhone uses the App Store. So with that, we cannot simply extend these two methods to our Android and iPhone classes. Now, rather than extending the download app and install app methods from the base class to our subclasses, a more refined approach is to implement these methods directly in our subclasses and override their functionality. So for Android, let's implement the download app and install app method with messages indicating the source, downloading and installing from the Google Play Store. Similarly, for the iPhone, we'll implement this method with the messages indicating the source, downloading and installing from the App Store. And this approach allows us to tailor the functionality of these methods to the specific behavior of each subclass. And this embraces the true power of inheritance and method overriding. Let's revisit the credit class example. This class has one class variable interest. The init method requires two input arguments, name and amount. Additionally, we have two methods, the getName and getAmount, which simply returns the name and amount of the object or class instance. And finally, there's a raiseAmount method that increases the amount of the object by 5%. And to create a new object of type credit, all we need to do is specify the name and the amount. And once the object is created, we can invoke the getName and getAmount methods to retrieve the associated information. And we can verify the type of the laptop object using the type method. And this method reveals that our laptop object is indeed an instance of a custom data type named credit. Now exploring further, if we use the help method on the laptop object, it reveals the details of the base class credit. This is because the laptop object is an instance of the credit class. The help method provides information on the required input arguments and the available methods of the class, offering valuable insights into the structure and functionality of our custom data type. And continuing our exploration, if we invoke the dictionary method of the credit class, this method provides insights into the class, displaying the class variable associated with it. Take note of the format of the key, which reflects the use of private variables. Additionally, the dictionary method reveals the method defined within the class, which offers a comprehensive overview of its structure. Next, we'll create a new class named Gadgets that inherits from the credit class. And this process of inheritance allows the gadget class to inherit the attributes and methods from its parent class, which is credit. And now to deepen our understanding of the gadget class, we can utilize the help function. And this reveals the structure of the gadget class, including the required input parameter when creating an object of type gadget. And an essential part of this information is the method resolution order or MRO, which outlines the hierarchy of superclasses and subclasses. Every time we invoke a method, Python follows this MRO. It first looks for the method in the gadget class. If not found, it will check the credit class. If still not found, Python then checks the built-in object class. The help function also details the methods that the gadget class inherits from the credit class, providing a comprehensive overview of the class structure. Once more, let's delve into the class information by examining the dictionary of the credit class. And this insightful method reveals the associated variables and method within the credit class. Now, if we turn our attention to the gadget class and inspect its dictionary, we notice an absence of variables and methods. This is expected since we haven't defined anything in the gadget class yet. At this point, it solely inherits from the credit class. And now let's put our knowledge into practice by creating an object of type gadgets and assigning it a name and amount. And we'll store this object in a variable named phone. And now let's execute this line. And upon checking the type of the phone, we observe that it is indeed of type gadgets. And now if we inspect the dictionary of the phone object, it will reveal the associated instance variables. Moreover, since phone is an instance of the gadget class which inherits from the credit class, we can seamlessly invoke the getName and getAmount method using the phone object. So if we invoke the getName method, it will return Samsung A7. And if we invoke the getAmount method, it will return 800, which is the amount that we specify when we created the phone object. And this time, let's create an object of type credit by specifying its name and amount. And once the object is created, we can invoke the getName and getAmount methods directly from the credit class. And observe that the smartwatch and the phone objects exhibit no differences, even though they were created differently. And this emphasizes the power of inheritance and the uniformity it brings to objects created from subclasses. In object-oriented programming, entities can have multiple is-a relationships. And to showcase this concept, I've introduced two base classes, father and mother. Additionally, we have a child one class that inherits from both mother and father, making it a derived class with multiple inheritance. And again, leveraging the help function on the child one class, it provides insights into the method resolution order. The MRO indicates the sequence in which Python searches for methods in the inheritance hierarchy, and the output reveals the MRO or the method resolution order for the child one class, demonstrating how the order in which base classes are defined impacts the resolution order. In this example, after child 1, the next in line is the father class, followed by the mother class. And now let's explore how changing the order of base class in the inheritance hierarchy affects the method resolution order. In this case, we have a child 2 class and we change the order of inheritance compared to the child 1 class. Now we first inherit from the mother class and then the father class. So now when using the help function on the child 2 class, we observe the updated MRO. In this scenario, after child 2, the next in line is the mother class, followed by the father class, and this change reflects the altered order of the inheritance in the child 2 class. And now in this expanded example, methods are defined in each class to showcase the inheritance of specific traits. Now the father class have or has a height method, the mother class has an intelligence method, and the child class has a coding method. And each method emphasizes the inheritance of specific traits. Now creating an object of type child exemplifies the inheritance of methods from both mother and father classes. Invoking the methods on the child object allows access to all available methods in the parent class. So this demonstrates that the child class inherits and can invoke the height method from the father class, the intelligence from the mother class, and the coding method defined directly in the child class. In this new example, we introduce two classes, employee and salary. The employee class takes two additional input arguments, the name and age, and it also has two additional methods, show name and show age. Then the salary class takes one additional input argument, salary, and has one method, show salary. Initially, these two classes, employee and salary, were not directly related to each other. So to establish a meaningful connection and create a relationship between them, we introduce a third class named database. And the database class inherits from both employee and salary, acting as a bridge to connect their functionalities. So the database class in its methods takes all the required input arguments for both employee and salary. And within this method, we invoke the init methods of both base class employee and salary, and also provide the necessary values, thus formatting a relationship between these classes. Now, instances of the database class have access to attributes and methods from both employee and salary classes, allowing for a more cohesive and interconnected structure. Now let's execute this code. And now let's create an object of type database. And once the object is created, we can invoke methods such as the show name, show age, and show salary. And again, these methods are inherited from the base classes employee and salary. And when using the help function on the database class, again, you gain insight into the method resolution order and identify the methods defined within the class as well as the methods that are inherited from its base classes. The MRO specifies the sequence in which Python searches for methods in the class hierarchy. Now it's important to note that while multiple inheritance can be a powerful tool in certain scenarios, it also has the potential to complicate code and lead to challenges in understanding and maintenance. In real-world projects, it is not as commonly used due to the complexities it introduces, and developers often refer or prefer alternative approaches or design patterns that achieve similar results with better maintainability. And object-oriented programming offers various concepts and tools such as composition, interfaces, and abstract classes, which can be leveraged to structure code effectively without relying on multiple inheritance. And before incorporating multiple inheritance, it is advisable to carefully consider the specific use case and evaluate whether there are alternative solutions that provide the desired functionality in a more straightforward manner. In this example, we have a class grandparent with one method height. Then we have a class parent that inherits from the grandparent class, and this class contains one method intelligence, and a child class that inherits from the parent class, and it also have one method coding. And this example shows the multi-level inheritance in Python. So when we use the help function on the child class, it provides insights into the method resolution order, and it details the method defined within the class itself and showcase the methods inherited from the other classes. And despite explicitly specifying only one base class for the child class, it inherits methods from the grandparent class. And this inheritance occurs because the parent class from which child class inherits itself inherits from the grandparent class. So now if we create an object of type child, all the available method from its base classes can be invoked. And this includes the height method from the grandparent class, the intelligence method from the parent class, and the coding method from the child class itself. And now let's delve into the concept of polymorphism. Although we've encountered it in previous examples, we haven't provided a formal definition yet. Polymorphism and inheritance are closely related concepts in object-oriented programming. They work together to provide flexibility, code reusability, and a more intuitive way to model real-world relationships. Inheritance establishes a hierarchical structure, and polymorphism allows objects of different types within this hierarchy to be treated uniformly. In this example, we have a class vehicle featuring a common method called move, and following that, we've created three subclasses: car, bicycle, and boat. And each of these subclasses overrides the move method, providing their distinct implementation. This is a good example of demonstrating the concept of polymorphism through the use of common interface or method. All classes, the car, the bicycle, and the boat, share a common base class, vehicle, which declares a method name, move. And this common method acts as an interface that all subclasses are expected to implement. And now each subclass provides its own specific implementation of the move method, and this is known as method overriding. Despite having the same method name, each subclass tailors the behavior of the move method according to the type of vehicle it represents. And instances of different classes can be treated uniformly through a common method call. In this case, we create instance of car, bicycle, and boat. Then we call the move method on each instance. And the specific implementation associated with the type of object is executed as we can see here in the output. Despite calling the same method move, the output is different based on the actual type of the object. And this is a key characteristic of polymorphism. And to illustrate another example of polymorphism, consider the new class bank account. In its init method, a balance input argument is required, and the class includes two methods, deposits and withdrawal. The deposit method takes a value input argument and increase the balance by adding the specified value. And then the withdrawal method subtract the specified value from the current balance, and both method prints the transaction value and the new balance after each transaction. Now let's instantiate a new object of the bank account class and set the initial balance. And following that, we'll attempt to deposit 100. And here we can see that we deposit 100. Now the new balance is 1,600. Let's also to attempt to withdraw 200. And here we can see the withdrawal value as well as the new balance after we withdraw 200 from our bank account. And we saw that both this method display the transaction details, which showcase the updated balance after each operation. And there are different types of bank accounts, and one example is the current account. In this context, we've created a new class current account, which inherits from the bank account class. And the init method of the current account requires an input argument for the balance. This method then invokes the init method of the base class, in this case is the bank account, specifying the balance for initialization. Additionally, we've implemented the same method name withdrawal in the current account class. It also takes an input argument value, and this exemplifies the concept of polymorphism, where we implement the same method name and override its implementation. In this case, we first check if the withdrawal value is more than 1,000, and if it is, then the transaction is not allowed and the user is advised to contact the branch manager. If the value is less than 1,000, it will simply invoke the withdrawal method from the base class and specify the value argument. Now let's execute this new class, and let's create a new instance of the current account with a balance of 1,500. If we invoke the withdrawal method and pass a value of 100, we've got a successful withdrawal transaction. But if we try to withdraw 1,300, we receive a message that we need to contact the branch manager, and that is because of the withdrawal implementation in the current account class. Now introducing another type of bank account, the saving account class, which also inherits from the bank account. Similar to the current account class, saving account features an init method with an input argument for the balance and invokes the init methods of the base class bank account. In the saving account class, we have a method named deposit with a similar name as in the base class. However, we override this method to add an additional 5% to the deposited value, and this showcases also the concept of polymorphism. Now, if we execute that, let's instantiate an object of the saving account class, specifying a balance of 2000, and following that, we'll invoke the deposit method and pass a value of 500. And in the output, you'll observe that the deposited value automatically has a 5% increase as per the implementation of the deposit method in the saving account class. And now that you have a good understanding of how to use OOP, specifically the concept of inheritance, I encourage you to apply this knowledge in your coding practice. Practice modeling entities with relationships using object-oriented programming. And there are plenty of real-world examples around you that you can use for practice. If you reach this point, thank you for watching the video, and in the next video, we'll delve into the advanced functionalities of classes in Python.